Hello and welcome to another video of Tutoring with Leah Cremona. Today we're going to talk about how to find the molar mass for compounds. Basically, we're finding the mass number in total for 1 mole of a substance. Okay, so that's just basically saying that in a compound, let's say for our first example, if we have lithium chloride here, we're just adding up the weight of lithium plus the weight of chlorine, and we find that those numbers would come from the periodic table, the mass number, right, for each lithium and chlorine. And when those numbers are added up, that would give us the molar mass, right, the mass in 1 mole of lithium chloride. So let's do this. Here, we need to find the mass for lithium and the mass for chlorine. Right, so in a periodic table, we see that for lithium, right, we have 6.94 as the mass number. Okay, and that's the grams per mole. And then for chlorine, right, if you see here, we have 35.45 grams per mole. Right, so these are just the units. Now we want to add this up together, right? So putting this in a calculator, we see that we have 6.94 plus 35.45, and that gives us 42.39. And remember, our final units are grams per mole. Okay. So example 2. Let's take beryllium fluoride. Okay, so we want to find the molar mass. Right, so we go through the same process for beryllium. Here, if you look at a periodic table, there are plenty online, just search periodic table. You can see that rounded to the second digit after the decimal point, beryllium is 9.01 grams per mole. And for fluorine, right, we have 19 grams per mole. Now, for this example, you might realize that we have a subscript after fluorine, which means that we have 2 fluorines. Check out my channel for the video about number, location, and elements, so that that video explains the meaning of the numbers based on their location relative to an element symbol. Okay, so we have 2 fluorines here. So that means that this mass is for 1 fluorine, right? So for 2 fluorines, we would instead have 19 times 2, okay, which would be 38 grams per mole. Okay. So now that we have our 2 numbers here, we can add them up. So 9.01 plus 38 is 47.01 grams per mole. Now for our third example, we can have, let's see here. And then we can ask ourselves, what is the molar mass for this compound? Right, so first we see what elements we have. We have V, which indicates vanadium. Okay, atomic number 23 on the periodic table. And we have oxygen. Okay, so what is the molar mass for vanadium? So we know that from the table it says it is 50.94. This is rounded to the second digit after the decimal point. And we know that because we have 2 vanadiums, we have to multiply this number by 2 to get the total number of grams for vanadium in this compound. Okay, and then we have oxygen, okay, which we have 3, it says here, right, given by the subscript directly after the symbol for oxygen. So we have, it says here 16, so 16 grams per mole, right, times 3, okay, and then we can calculate these values and then add them up. Okay, so for vanadium, we have 50.94 times 2, which gives us 101.88. And that would be grams per mole. Then for here, 16 times 3 is 48, okay? 48 grams per mole. So in total, right, we add these two numbers up to find the molar mass. So we have 101.88 plus 48, which gives us 149.88 grams per mole. Alright, so then this would be our molar mass for vanadium 3 oxide.